Good day, my name is Taku Abinda, and today I'll be showing you a simple linear regression tax from Spark Foundation. And so this tax is about the predicting the percentage of the marks that the student expected to score based on the time that he studied, the number of hours he studied. So it's just a simple regression or tax. So you look at the first here, we have the libraries that are important for this. That's Pandas, Scikit-learn, Matplotlib, Seaborn. So we loaded data from a URL, as you can see, and this is an overview of the data set. So you see we have the various lines of code for the overview, and then there's a result below. So we have the two variables, which is the hour and the school. We have the description of the data set, which is the minimum, has the minimum, the maximum standard deviation, and so forth. So we don't have any missing value in this. Okay. Now we see we're checking for distribution in the data set. We found that for the hours and the school distribution, you see, we have distribution of hours and distribution of school. We know that in the distribution of hours between and or let's say between two and 4 hours were uh, frequently occurring in a data set, and within the school distribution we found that between 20 and 40 marks, these were uh, very frequent in the data set. So we see the KDE line is indicating that we have a high distribution at this point. All right, that's that for distribution. Now also have a to check for relationship, the exam relationship within the data set. So we feel that we found that there's a positive relationship between the hours and the school, as you can see from the shape of this. Then, so as the student study for more hours, that's how you get more school as well. So as this increase, the hour increase, the school increase as well. There's a positive correlation between the hours and the school. So the box plot expand to explode groupings of hours and school. Then we check for all layers. So we find that there's no outliers in the data set. There's no outlier in the hours, and there's no outlier also in the school. So after that, all of that basic analysis, we come to train the model. So we split our data into a feature of X and a Y, right? So after splitting our data set, we also split the training and testing data set into 80 and 20. So our 80 is for training, and then 20% of the data set that we are splitting is for testing as well. Okay, so I'll see what size is zero point 0.2. So we create a linear model. So that's model is equal to linear regression. All right, so we'll fit the model with the train, the train set, the X train and Y train. That's how we use to fit the model. Okay, so we get coefficients. Then after that, we make a prediction. So we make a prediction on our test set. So Y predict equal to model that predict X test, right? Then we evaluate the model, performance of the model using our square method, which is to check how well the model fits. And we also predict the model, predict the score for a specific hour, which is 9.25 hours, as you can see here. And then we print it out. So we have our results. So the predicted score for if a student studied for 9.25 hours will be 92.3 score would be the score or the mark of that student. So that's the first tax. Thanks for watching.